So, very good morning. Today I will discuss about the Corey-Fuchs reaction. This reaction is very important for CSIR June 2020 NET upcoming exam. So, what is Corey-Fuchs reaction? It is a very interesting reaction. So, this reaction particularly convert the aldehyde into alkyne. So, here the aldehyde and the reagent will be CBr4 PPH3 triphenyl phosphine. Then this is the intermediate, and finally butyl lithium water to form alkyne. You just see in aldehyde there is a one carbon, R and one carbon, but here after the formation of a product from aldehyde to alkyne, triple bond alkyne, that is R and two carbon. Here is two carbon, one is alkyl group, you just excluded that alkyl group, that is here is only one carbon, but here it's two carbon. In alkyne there is two carbon, that means there must be a homologation of carbon. So this reaction, Corey-Fuchs reaction, is very interesting in organic synthesis because this is particularly homologate the carbon atom, that must be increases the number of carbon atom. Here is only one carbon atom, but here after the reaction, after the formation of alkyne, there is two carbon atoms. So there must be a homologation of carbon atom, there must be increases the number of one carbon atom, there must be a homologation of one carbon atom, or there must be a increases in the number of one carbon atom. That is very important. So then comes to mechanism. The most important part of this mechanism, the formation of a carbene. The reaction undergo through carbene intermediate. So first the triphenyl phosphine react with CBr4. According to that mechanism, it must be attack the bromine and CBr3 will be broke, so resulting in the formation of a PPH3 plus single bond Br, and that part CBr3 minus will be formed, and then removal of a bromine, formation of a carbene. This is the carbene part, CBr2 carbene. This is the carbene part, and this is the first step, is very important. Then come to the second step, it is very important, formation of a phosphor yield. So then the carbene form in first step must react with PPH3 to form phosphorus yield. So this is Wheating reaction type. This is just a big brother of Wheating reaction. It's a very important, the step 3, and the yliid form, phosphorus yliid form must be react with this phosphorus yliid form must be react with, you just see the step 3. So after the formation of a phosphorus yield, it must be react with aldehyde, then the formation of that product, that is the intermediate product, I was already told that, and finally that is react with butyl lithium and water to form the product alkyne. This is all about mechanism. Then come to deuterium labeling. So what is deuterium labeling? How you can do the deuterium labeling? What is the major role of deuterium labeling? So deuterium labeling is nothing but the intermediate step. In intermediate step, you just create a compound like that. According to that intermediate step, here R is the benzene aromatic compound. Here R is the aromatic compound. So just like that, after lithiation, the product will be formed. One of the bromine atom of a vinyl carbon must be substituted by lithium atom. Then alpha elimination takes place. What is alpha elimination? Alpha elimination is particularly takes place to form carbene. Here alpha elimination takes place, lithium bromine will be removed, LiBr will be removed, so there will be formation of carbene, and carbene is the major intermediate stage of this reaction. Then finally there will be 1,2 shift takes place. 1,2 shift takes place between these two deuterium and this carbene. 1,2 shift, it is very important, and finally the product will be formed alkyne. That means aromatic substituted alkyne, and here the deuterium will be substituted in presence of in the place of proton, hydrogen atom. So from this it can be observed that it can be concluded that means the formation of alkyne will be takes place from deuterium labeling. Deuterium must be labeled at hydrogen atom of alkyne. Then go to problem from different source. This problem must be collected from different books, different source. It is very important. Must watch this video at the end. So this is a reactant. It must be react with a 2 equivalent CbR4, 4 equivalent PPS3, CS2Cl2. Finally, the intermediate stage will be formed. You already know that. I was already told that. It is a very simple process. This first step, I was already told that it is a Coriolis reaction. And finally, the LDA, lithium, 3 equivalent of LDA, lithium diisopropyl amide, and minus 78 degrees Celsius temperature takes place. Why LDA will be we can take? This is due to the formation of disubstituted bromine at a vinyl carbon to form this is alkyne. So from the formation of that intermediate to that alkyne, benzene substituted alkyne, the lithium substituted either LDA, either butyl lithium you can take. When you go to problem, so that Coriolis reaction must be associated with either oxidation, either reduction, either hydroboration oxidation, or protection, deprotection. So problem comes in CSIR net or gate, not directly from Coriolis reaction. It must be included this part: oxidation, reduction, protection, deprotection, and some of the side reaction. So this is the compound. First, the reagent given KHMeI. So KHMeI here. You can know that here KHMeI, KH is the base. It can abstract proton from OH. This is the acidic proton. This OH proton is the acidic proton. Then the O minus will be attacked to methyl, and methyl iodide, iodine will be good leaving group. It can be removed. So formation of a OMI. And the second part is the hydroboration oxidation. It is very common known hydroboration oxidation reaction. 9 BBN, that means the boron can be added this double bond. Markovnik rule, you know that Markovnik rule, anti-Markovnik rule. So then after oxidation, the removal of boron part to form alcohol. This is primary alcohol. And the third step is very important. T-tap and NMO, TPAP and NMO. This is a popular common known oxidizing agent to formation of a primary alcohol to aldehyde. And the fourth step is very important. That is Coriolis reaction. CbR4, then N-butyl lithium and methyl iodide. According to that, formation of aldehyde to alkyne, and finally the lithium in form in alkyne that attack to methyl to form methyl substituted alkyne. And the fourth part is very important. It comes to regioselectivity. So this alkyne react with lithium aluminum, lithium liquid ammonia to form that is E substituted double bond. So lithium liquid ammonia reduce triple bond to E substituted double bond, and finally again the TPAP NMO, that is the oxidizing agent. And yes, lithium ammonia can do two things. It can reduce the triple bond to E substituted double bond, and it can also deprotect this OBN group, that OBN group to OH alcohol. That means this triple bond converted to double bond, and that E substituted double bond, and that OBN can be deprotected to form OH, primary alcohol. And finally the TPAP NMO converted this primary alcohol to aldehyde. Again I can told that lithium liquid ammonium can be converted triple bond to E substituted double bond, and finally the last step TPAP NMO that converted OBN here deprotected by lithium liquid ammonia, it is converted to primary alcohol, and using oxidizing agent that primary alcohol converted to aldehyde. So it is a regioselective reaction. Here oxidation takes place, here hydroboration oxidation takes place, here Coriolis reaction takes place, here lithium liquid ammonia regioselective reducing agent, here oxidizing agent. That means this type of question must be comes in CSIR net. This is another very good example must be comes. So many chance to comes in CSIR net exam. So this compound must be react with the DMSO, oxaryl fluoride, NR3. You all know that these are the Fuchs oxidation. These reagents are the Fuchs oxidation, and Fuchs oxidation can be converted this primary alcohol here to aldehyde. In the second step, this is again the PPR3, PPS3, CBr4, butyl lithium. These are the Corey-Fuchs reagent. This can converted aldehyde to alkyne. That means here only one carbon atom. Here homologation again takes place. I was already told that increases of one carbon from here to two carbon. Here is 1, here is 2. That means homologation of carbon takes place. And in the third step, it is very, very important. PTSA. PTSA can be used to deprotect this group. Here deprotection takes place, and again this there will be conversion of OH and OH. Two OH group is present, and again it will be protected by TBSCl to convert OTBS and OTBS. First deprotection takes place by PTSA, then it converted to OH, then OH, 2OH will be protected by TBSCl to convert OTBS and OTBS. So here three type of reaction takes place. First is Fuchs oxidation, second one is Corey-Fuchs reaction, third one is deprotection, again protection. It is very, very important. You can just observe. And the fourth one is excellent question. First, this compound must be undergo Corey-Fuchs reaction. Again, homologation takes place. You know that here only one carbon atom in aldehyde, it must be increases to 2 carbon atom. So in all the step of Corey-Fuchs reaction, there will be homologation takes place. That means there will be increases of 1 carbon atom. Homologation is nothing, but there will be increases of 1 carbon atom. Here in only 1 carbon atom, here after formation of alkyne will be 2 carbon atom. Then this reagent is very, very important. CP2ZrHCl. It is a popular reagent known as Fuchs reagent. You can study in Carruthers book or in Zweifel book. This is B-cyclopentadienyl zirconium hydrochloride. Here hydrozirconation of terminal alkyne takes place. That means this reagent can be hydrozirconation takes place. This is terminal alkyne. Then this H and this CP2ZrHCl added in this triple bond to formation of a double bond. Here double bond. This is not something mistake. I can correct that. So here is double bond, and here that can be single bond attached with ZrClCp2. And again it react with iodine, and that ZrClCp2 can be substituted by iodine. So this is again I can told that Fuchs reagent. Hydrozirconation of terminal alkyne takes place. This is a regioselective and a stereoselective reaction. This is regioselective. Why? Because this is particularly added to the terminal alkyne. Only terminal alkyne this reagent will be added. And why it is stereoselective? Because it can give only the E product. This is the E product. So this reagent is a regioselective and a stereoselective reaction, and included this Corey-Fuchs reaction. It is a regioselective and a stereoselective reaction. Regioselective for alkyne and stereoselective terminal alkyne, regioselective and stereoselective for E substituted double bond. And this is a Corey-Fuchs reaction, including regioselective and stereoselective reaction. And finally, iodine will be formed and substituted by ZrClCp2. This is the another important question. Excellent question this is. So this long chain aldehyde can be react with the CBr PPS3 N-butyl lithium. This is simply Corey-Fuchs reaction, homologation of carbon chain. This form alkyne, then it must be react with this part is important. PHN3CuSO4 sodium ascorbate. So this addition reaction, this is the product formation. What is the product formation? I will give in mechanism below. This reaction is called as Fuchs cyclo addition. This reagent will be undergo cyclo addition with their terminal alkyne, and that addition is called as Fuchs cyclo addition. It is a copper catalyzed azide alkyne cyclo addition. It is a copper catalyzed azide alkyne cyclo addition reaction. Copper reagent here used. So here this alkyne can be added to that PHN3. I can write just like that, N triple bond N plus N PH. Here the cyclo addition reaction takes place. You just see that N minus attack here. This formation of this closing ring compound. So here the three type of reaction will be takes place. One is the Corey-Fuchs reaction, formation of alkyne, then it undergoes cyclo addition reaction, Hugin cycloaddition reaction. It is a very important thing must be comes in CSIR net exam. This is the cycloaddition reaction. You can see that. And this question is a super question. You can just see that this compound first react with the PPS3CBr4ET3N. This is Corey-Fuchs reagent. Second one is the dibal H, is a reducing agent. Third one is the deprotecting agent TPAP in tertiary butyl NF. And fourth one is the N-butyl lithium. Lithiation takes place and aqueous HCl. So you can see step by step. First step you can go. This is the compound. This is the compound. Starting compound. You can use PPS3CBr4ET3 and this is a Corey-Fuchs reaction. There is a homologation takes place here. There will be carbon-carbon double bond bromine takes place. This is the intermediate step. Then it must be react with the dibal H, is the reducing agent. This reducing agent can reduce this ester group, this ester group, this ester group to alcohol group. The reaction will take place at a low temperature. You can follow the book Caruthor, you can follow the book Clyden, you can follow the book Duifel. This is a common oxidation reducing agent. This is a common popular reducing agent. Can reduce the ester to alcohol, primary alcohol. And the fourth step was that primary alcohol can be reacted with TBAP. TBAP is a deprotecting group. It is particularly used for a deprotecting group, TBAP. So here TBAP can be used, and then N-butyl lithium. So this step is very important. Here TBAP is used. TBAP is particularly used to deprotect the silyl group, silicon related group, OTMS, trimethylsilane. You can deprotect this to convert OTMS to OH. And here deprotection takes place, then lithiation takes place, excess lithiation to convert this double bond to alkyne, and aqueous HCl, protonation takes place, lithium will be removed and that alkyne will be formed. So here this reaction 3 to 4 step will be takes place. Before we can see that the dibal can be used, reducing agent, Corey-Fuchs reaction takes place, this is deprotection takes place, and here again the lithiation takes place and the final product will form. So you can always understand that in Corey-Fuchs reaction or whatever may be in organic chemistry, the reaction will come. This is not come directly. They can include oxidation, reduction, protection, deprotection, something side reaction. So this reaction is very important. So I will do video specially. The intention is that to help the people who are financially poor, will not attend any coaching, and this critical situation like corona pandemic, they can read and they can see the video very well. So please subscribe my channel for more video to encourage me, for you people to whatever I know to give something about chemistry, and please add comment at the end of my video. Whatever anything added to my video, or whatever may be wrong, or whatever I can improve for my video for you people. Thank you very much.